I will be dealing with an issue that I discovered about 5 years ago, where we try to build a kind of virtual construction site for sewage projects. And we've heard sewage projects, about sewage projects over, I think, also your presentation this morning, in The Hague, sewage projects. And we were interested in sewage projects because although we think this is a project run by the municipality, in fact it's not a project. It is a whole host of projects of utility owners with their own contractors, and they try and work on the same location. And in fact there's no hierarchical structure that coordinates the work in between. So they improvise themselves through the project, as long as if you say the boundaries, if there's a fence, then you could name it a project. And it's what can we do to improve this strange coordination situation? That was one of the main issues. And from this, I think it might be good to show you right away. We started off with modeling what needed to be done, what was there. We tried and get all the information from the contractors that should be involved, which was quite difficult because they didn't want to think about a project in advance. We built this into a 3D model. That 3D model is then cut in all kinds of elements. These are put into a system that's called, MS Projects. These two are linked, and then you in fact get a kind of a virtual construction process, and this then could be optimized with the contractors and the utility owners to more or less get a more coordinated process. And of course it's interactive, and we trained people from the municipalities, and we trained people from contractors in the hope that they would also start off with this type of project. But in fact, and that's what I want to talk to you about today, it seems quite simple and it looks quite nice, but it's quite difficult because you run into all kinds of practical issues. For example, we found out that most of the municipalities work within the Bentley family, and most of the contractors work within the Autodesk family. So that if you want them to work together, it's very difficult. They like to think in 2D. They don't want to do 3D stuff. They first need to learn 3D, which is very difficult because what would be 3D? Is it the depth? And we don't know the depth. So we don't know the depth. How can we model this? You should try and more or less estimate the depth. So that was about these practical issues. Then what I will be talking to you about, and how could we further this practice, and how could BIM and geoinformation come together in this. I'll first need to put it on presentation mode. So it's from guessing where all the stuff is to Geo-data in 3D and putting it into BIM models. This is me. We live close to the German border, as you see in the top picture, and it's one of the things that a university likes to do, is to make a virtual university. And we thought, wouldn't it be nice if we could do this also for the stuff that's beyond our feet. Myself, I must first confess, I'm twice an engineer, I'm sorry. But I went a bit astray and look at things from the economic organization perspective, or market dynamic perspective, which is how do markets or market forces shape technology advancement and adoption of technology. And furthermore, as you can see, I'm very much involved in all kinds of projects, also in the Rijkswaterstaat, and co-initiated several innovation programs, for example, also in the use of new technologies in asphalt paving. This picture you've seen before, in fact, it was reused by one of the previous speakers. And this is in fact what I want to end up with. That will be in about 20 minutes, I think. So I think we need to push the envelope in surveying technologies and education. would be detection, measuring before model. Then we need to model all this type difficult thing. It's very difficult to use to scan data to create models. Then we need find a way, because if we talk about what's your virtual model of what's your asset management system, I can show you. This is the asset management system of all the utilities of our university. This, in fact, is one AutoCAD drawing with about, I think, 2,400 layers. That's how we do it at our university, which is, in fact, already very well detailed and very comprehensive. Although, you know, we see all these lines, but for many we're not certain where they are. We know certainly that they are not lines but have a certain dimension. So we have poly lines on this, and if we want to make this 3D, then we also have to give these poly lines a dimension. And then again, if you try and do this, you in fact have to pick up every line and then create a diameter for this. This is very complicated. We need to educate our students not only from icon projects, such as Crossrail, but also about the projects as they go on close to us in the cities. And we need to make the step from digital drawing software to GIS applications and views. And we have to make the step from precise and passive towards more fuzzy logic and context data to advance to action. My experience is in this field of surveying, there are a lot of trained surveyors. And they've done in Dutch, we would say, lotmeten. And these people want to be very precise. And if it's not precise, it doesn't exist. So that what it does, it hampers your logic and your reasoning if you say, you know, if we don't know it precisely. So, for example, can't you try and model the depth of this pipe? You say, no, we can't, because we don't know how deep it is. You know, what's the depth? Oh, is it very deep? Is it 8 meters? No, it's not. That would be very deep. Is it 10 centimeters? No. Can you then please try and estimate where it is? So they find this very difficult. So that also is difficult, the adoption of 3D models for the underground. Why do we do this? We see a number of drivers, societal drivers, so that there is quite annoyance about excavation damages and hinders in projects. I felt the estimation that it costs us about €500 million a year, still quite modest. It might be more. We have to implement new legislation. There are all kinds of initiatives of utility owners to map the underworld. There is a popular migration towards cities, so will be more loading on our current infrastructures. That needs to be upgraded. I'll come to that. We see more and more that owners take a life cycle approach to their assets, and they want to monitor their assets and model their assets. So BIM and asset management are fusing. We see an advancement in all kinds of new technologies. Sensors are becoming cheaper, becoming better, more precise. Data crunching becomes better. And then in internet also we have the 3D breakthrough that wants to do more about 3D, what we like. Then we also have something that pushes us is together with Regenfiber, one of the fiber to the home providing companies. They sponsor a program where they in fact sponsor 10 PDM students or candidates, and our university wants to do something about, as I told you, creating a kind of virtual university and use Living Lab, the campus's Living Lab. Coming back to the theme of today, smart cities, it's very popular, and if you look at the discourse in smart cities, you see there's a lot about the Internet of Things, there's a lot about pervasive networks, the smart devices, sensors, monitoring. There's a lot about, as this morning was talked about, citizens empowerment, governance, so who in fact makes decisions in the city. There's a lot about sustainability and energy transitions, mostly about electricity related to smart grids, where all the mathematicians get in, so you can do all kinds of optimizing. And there are some meta themes in these courses, which is particularly about scientists talking about scientists talking about smart cities. But these are the main discourses, and a number of things are overlooked. These are the planners' wet dreams. We've seen some this morning also. But this is the bare reality. This is the bare reality. If you are in a city which is quite mature, then some of this is in our neighborhood, some of this is in Antwerp, I think some is in Amsterdam. This is the reality where they need to work. This is the reality where they need to, in fact, if you think in advance, plan and design, where the thing needs to be put into practice in action. You think we have a lot, we will get even more. These are our concealed servants, or hidden or hiding servants in our society. So we already have about 2 or 3 billion euros of underground infrastructures that we mostly are not aware of. And there will be a lot of stuff added to it. And at the bottom, there is the Hyperloop system. Does anyone know what a Hyperloop system is? We had Steve Jobs, we now have Elon Musk, the guy from Tesla. And he thinks it would be great if we could more or less connect all cities with these kind of, in the past we would call it a kind, we would say bottle posts, these pipes where you shoot these small elements through. It's a kind of transportation system with pressurized tubes, and then you shoot all kinds of boxes from one place to another. So it is already crowded, and more is added frequently and continuously. What's the state of it? This is a US picture about the state. The American Society of Civil Engineers does inventory of the state of the infrastructure they have. Most is poor to mediocre, and some close to fail. Bare reality. In New York, we saw pictures from New York, 400 water main breaks per year. London, about 1 or 2 cable box or pavement explosions a year. We have a measured direct cost of 130 million excavation damages in the Netherlands. Early this year, someone's still aware of the Holborn fire. It was a cable fire in the city of London. No one was aware that that could happen. No one knew. At least the fire brigade was not aware how to extinguish the fire. Then we had quite a big blowout of a pipe hit during digging Bus F. Last year in Ludwigshaven, there were all kinds of leaking gas mains. We had several accidents in the Netherlands, a few of them in The Hague. Because what we do now in the Netherlands is we try and put these large concrete boxes into the streets and roads where people can put their waste in. So you don't have a waste bin at home. You have to, you're part of the waste logistics yourselves, but they now have to put all these things that are 2 by 2 by 3 meters and fit them somewhere in the paving. And that might go wrong, so they hit gas main, and you can see in one of the pictures. Some people, several to the hospital and houses, not fit for living anymore. We had several water bursts or bursts of water mains in Amsterdam, Antwerp recently. So that's a bare reality, and this is where the picture is from. The picture is from one of the, it's a cartoonist, I added it to text boxes. It's a high level boardroom conversation where smart city is the solution or the magic bullet. Yeah, let us become a smart city. But what's the inconvenient truth? Smart cities are not green fields. So a blueprint is only halfway there. Smart cities are not green fields. They are evolving phenomena where people live together. They are already full of technologies. In fact, crowded with technology, structures and governance. And there's you need to acknowledge that these are there, and that's the first step for the smart city. There's been experiments in building smart cities, and they looked backwards and said only 2% of what was built there was really related to the smart topic. The other things were infrastructures you had to put in, of the 98% anyway. So many cities already struggle hard to maintain functionality and renewal of their installed base of infrastructures. And they do so while maintenance budgets are cut. There's an increased loading of these infrastructures due to population increase or the urbanization. There's climate change, and also if I watched the BBC News over the past days, and we could see what happened in Cumbria. I think it was quite shocking. The real space is already crowded. The governance space, because although we've regulated a lot in this country, we've not regulated the space underneath our paving, our parks, our roads. If a utility owner decides they want to put utilities in, the municipality has to allow this. The municipality can tell the utility owner where to put this. Some municipalities do, because they want to keep control over where all the stuff is. Some don't, because if they tell where they should be put, then the utility owner might bump into other utilities and claim that the municipality that they more or less directed to a certain kind of say design that was not appropriate. There's a lack of information about the actual real situation, and you see the acting, so really doing stuff, so really putting new infrastructures in is quite a painful process and gives quite a lot of headaches to governance and civil service. So regardless of the ambition of becoming smart, I don't know, nobody really knows what it will be for the future. We can project, but we know all the things. For example, smart grids. If we think of smart grids, someone needs to put in the cables to make this happen. If we think about the Nairobi project, with, as explained with the Matatus this morning, someone has to put in the telecommunication network to make this happen. Even the roads need to be there for the Matatus to drive. And that's painful, it's costly. So what could we do? We could make the movement far, let's say, smoother if we can make it less painful. Looking at the issues that we need to solve, is there is incomplete information. It's incorrect if we have incomplete information, for example, about the existing infrastructures, then of course we will have incorrect and incomplete design. We have project tendering and planning based on the design and based on the assumption will not be correct. We have nasty surprises during projects, often cables. Only yesterday when I walked along the campus I saw two men, one with a digger and one with a shovel, and looked, there were two pipes, they were broken, and I asked, "Oh, did you hit them?" No, we have to make an entrance here. And we're just waiting because there's a KPN, there's a telephone cable, but they don't know whether it's live or not. So they just wait till someone can tell them if they can cut the cable or not. These are the things in practice. So then you have hold-ups, improvisation, delays, overruns, cover-ups, and these are difficult to solve because there's no hierarchical control. Due to privatization, we have all kinds of subautomizations. There's no overall strategy or vision. There's overexploitation, free rider behavior. Because due to privatization, you see a number of these utilities are now exploited rather than maintained. Spillovers. There's shifting of risk and blame and responsibilities as a claim culture, and I know many of it. My experience, if I tell servants from the municipality about these issues, they first, for about 15 minutes, they'll they're very aggravated, and they give me example after example after example, and they can all kinds of, you know, things that they feel they very much agree with me, and then they more of glaze over, they sigh, and they wish me a lot of luck. Because they know that it is this way, and so I try and do something about it. So can we make this less painful? How can we do it? How can we mobilize technologies to help this improve coordination, make this thing better? And so first of all, we noticed that students are not at all interested in this. We have courses and programs related to BIM, but the underground is not sexy. In fact, it's something that they don't know about. So first we have to educate them that it's there. So we created a 10-week course in the third year, and we start, let's do something about this, and we use the metaphor of non-invasive surgery. So where you try and more or less, there's just people are scammed nowadays with echo and all kinds of stuff. So you have a clear picture where you want to operate, and then try to be more precise, you know, like non-invasive surgery. So in this course we teach them about smart cities a bit. Then in the middle part, they can choose from different technologies. Then they need to work on projects that are in fact provided by the people from industry. And we now have about 30 students starting. And what are the things that we now try and advance, that we have to advance, to detect and trace cables, pipes and structures, to map and model the situation realistically in 3D, but model in fact first measure and then model. Then we have to, if we want to go into asset management type of stuff, model the networks and the functionality and the functional capacities, the operational behavior and functionality, how they, in life cycle perspective, you know, decay in functionality or in the robustness. There are all kinds of interconnections, for example, in the two Apeldoorn cases where a pipeline burst, then a water main burst. Then, of course, after that, rightly, the gas main burst because there was no support, because all the water flood, all the soil was flooded away. And then some of the sand came into the gas pipes, and then that goes into the house. So it's quite a mess because there's interconnectedness. We do have still stuff laying around, asbestos mains, I think asbestos water mains. You need to know where they are, because if you hit them, there's quite a problem. And if we are able to do so, we can optimize and coordinate interventions. And being a university, we try and find focal points for innovation. We try and use the university, which is a small city in itself, and we try and use it as a living lab. So we invite technology providers to give us stuff that we can try and we can use and train. And we do that not just for our students, but also for, in Dutch we would say, the lower vocational course of middle vocational course, MBO and HBO. So they can do some of the scanning and some of the modeling. And in the meantime, we will try to give them feedback to the utility or to the technology providers. Guys, you create a kind of a ground penetrating radar. There's a small rugged notebook, and all the information is in one corner, and the people just keep zooming in and out. That's not practical. Can you think of something better? Your project will improve. And in this way, you can kind of blend the situation of technology development, education, and research. And it would be great if we could look into the soil and see what's there. This is some of the stuff I showed you up front. And the ambition, of course, as I said, is what is now felt, particularly also in the larger owners of assets, as Waterstaat. How can we, in fact, map and monitor our assets, not as we design them, but also as we use them, and we need to maintain them. So here we are again, where I started. I feel we need to push the envelope. The survey and technology and detecting technologies are now rapidly advancing, but there's a kind of innovation failure because they're a bit too expensive still. So the industry still is very reluctant to put them into application, and if they're not used, they will be not improving. So if we can make this positive spiral happening, we need to improve and apply. We need to find ways to, has any one of you already tried once to interpret ground penetrating radar data? Yeah? How is that?
We have one system
Yeah.
in the office, but it's when you see a parabol,
Yeah.
this cable.
So it looks like almost a wave pattern with all kinds of grey parabols.
It could be also in the big stone.
Yeah. And then you have to think, you have to look at it, think about it, and you have to make sense of all these pictures and these 2D slices. And I think you can measure them, but for example, if you do this in a city, you're in a city, GPS positioning is already quite troublesome. So this is a very laborious task. I know some of the companies that do this. Bob Exact, which is a company in the Netherlands, which has a MALA ground penetrating array radar and a LiDAR system, and they combine this. But for the ground penetrating data, they have to send the whole stuff up over to India. And there are some people who are looking at screens and trying to put points in. Then you get point clouds, and point cloud needs to be translated to, is it water, gas, what's the material, and so on. So improving these technologies would be key in mapping the underworld. Then one of the things that we need to also acknowledge that we have an installed base of software, which is very vector-based and polylines. Even in Click, if you have one polyline, you're not sure whether it's one big cable or maybe 3 or 4 placed in a space of 90 centimeters. You don't know how deep it is, what the depth is. So how can we make them realistic dimensional object representations? I know, for example, on Schiphol they do have maps, just as Click, where all the lines are drawn for their telecommunication cables. There's one line, and you have a flag and about 40 to 50 numbers. Or in fact, this is a bundle. This is not one cable. So how can we make this realistic representation? We need to be aware and make our students aware that most of the work, in fact, Rijkswaterstaat does great work, does a lot of work, but overall the cities and municipalities do more work than Rijkswaterstaat, if you put it together. And the other thing, we need to move away from digital software, drawing software, to database applications. You're the industry that provides, and I see a number of the people from this industry that provides that. So you can help to make this happen. And we need to be aware that it would be great if we could do something about more fuzzy logic programming or fuzzy logic reasoning. For example, if you have a crossing of several utilities, if you have a polyline structure, then it seems all in one layer. But if you have the dimensions, you already know you have a kind of a package that you have to deal with, and so you get some sense of the total space that it requires. Well, this is what I would like to tell you. Thank you very much.